Hello and welcome to this course. My name is Ajay Warrior and I'll be your instructor in this course. I'm a computer science engineer and I've been teaching in Udemy for the last 4 years. I have several other programming courses and they're all well rated by the students. So this course is on R programming and my goal is to cover R in the minimum amount of time. So in 3 hours, you'll be very well prepared to enter the world of data science and start making your own projects. Now, let's talk more about the course. Who is this course for? This course is for beginners. Now, I know. Why am I stressing this? It is even in the title. It's mainly because I've been getting reviews from students where some people are complaining that this course is too basic. Well, the idea is that the course is for beginners, so it's for people with no programming experience or people with programming experience but not with art. So my goal is to introduce you guys. So don't expect advanced level data science project from this course. It is to solidify the basics so that you can learn everything else on your own. Okay, now the next thing to know about this course is that this is not a machine learning course. In the final section of the course, I will introduce you to machine learning and we'll make a machine learning project. But that project is there so that you guys can use everything that you learn in this course to actually make a real world project. My goal is basically to take you from a beginner with no experience to a level where you're comfortable with looking at code that is written in R and making sense out of it. So that is the goal of this course. And we will introduce you to machine learning and we'll build one real world project using everything that you learn in this course at the final section. Another important question is why should you learn R? R was designed for data science. So if you are planning to enter the world of data science and you have no programming experience, R is a good place to start. It's also very beginner friendly and it has great documentation. Awesome. So that is everything that you need to know before taking this course. I'll see you inside and we'll start our journey of learning R programming. Thank you for watching and have a wonderful day.
Hello and welcome back everyone. So in this lecture, we'll be talking about the data types in R. Whenever you're starting to learn a programming language, the very first step involves understanding the different data types that are associated with that language. Now, what do you mean by a data type? Basically, it means the different types of data that can be handled by the programming language. Now, most of you might have experience with some other programming language, so you must be very much comfortable hearing the term data type. But for those who are not, for whom R is their very first programming language, don't worry about it. It's a very simple concept and you'll grasp it without any problems. So let's start off. What are the different types of data in R? Okay, so R programming supports mainly 6 different types of data. Starting with logical data types. So what are logical data types? They're basically true or false. So basically, they can have 2 values, which is either true or false. Simple, right? The second data type is numeric. So numeric is basically any type of numerical data. Now integer data type is specifically for integers. It can only handle or store integers. The fourth one is complex. You're very much familiar with complex numbers that are used in mathematics. So there is a data type in R that can help us store complex numbers. Now the fifth data type is character, which is pretty much basic, right? It's a collection of characters. It can be a word, it can be a letter, it can be anything that is enclosed in single or double quotes. So anything enclosed in single or double quotes is a character in R. Now finally, the last data type. Now this might be tricky for you if you are not coming from a CS background. It's called row. Now what row basically is that when you are storing something in your computer, it is being stored as bytes. And what are bytes? Bytes are basically a collection of zeros and ones. Computer stores every piece of information it gets in the form of zeros and ones. So basically, raw data type is an internal representation of the data that we're using. Now, don't get too worried about all this because in our next lecture, we'll be making use of these data types in our program. So we'll open up RStudio and we'll use these data types in our program. And when you do that, you'll get a very clear idea of what each of these data types are. So don't worry if you're stuck now. By the next lecture, everything will be clear to you. So I'll see you in the next lecture where we'll be actually using these data types. So thank you for watching and have a wonderful day. Hello and welcome back everyone. So as promised in the previous lecture, in this lecture we'll be actually making use of the data types that we learned in the previous lecture. Okay, so I have RStudio opened up here and I have a new R script opened. So to do that, you can go to File, New File and click on R script. and you will have a new file generated for you. Okay, so we have a new R file. Now I'll show you how data types work in R. So to start off, the very first data type that we talked about was logical, right? So here's how logical data types come into play in R. Suppose we do this. So what is it that we have done here? Basically, we have something called A, and it has the value true. Now, this part A is known as a variable. So what variables are basically their names that can have a value. In any programming language, variables are names that hold a certain value. And why does it have the name variable, you may ask? It is because their value can keep on changing throughout the program. Say for example, A can later on have a value 5. And then later on, maybe it can have a value 10. So the value of A can keep on changing throughout our program, which basically means that A is having a variable value, hence the name variable. So variables are names that can store value, and data types come into use in the creation of these variables. So let's trace back to our very first variable A, which has the value true. Now, like I told you, true and false are part of the logical data type. So what that means is that A is a logical data type variable. Now, to run this code, all I have to do is press on Control-Shift-Enter or Command-Shift-Enter if you're on a Mac. And you can see here we have our result. We have a variable created, A, having the value true. Now, to display the value of A, all I have to do is simply type in A and again press Control-Shift-Enter, and we get the output true, which is basically the value of A. So A is our variable name and true is its value. Now, where does logical come in, you might ask? So to check the data type of our variable in R, there is a very simple way. All you have to do is type in class, open and close brackets, and inside you type in A. Press Control-Shift-Enter, and you get the output logical, which basically means that our variable A belongs to the class or data type of logical. So this is an example of a variable that is of logical data type. So similarly, we can put to use all the other data types that we learned in our previous lecture. For example, if you want to create a numerical variable, all you have to do is go in and type A equal to 5. Control-Shift-Enter, and we have it created. We check the value by simply typing in A, Control-Shift-Enter, and we get the output 5, which is basically the value. Now, if you want to know the data type, you can simply go class, and then inside opening and closing bracket, you type in A, again Control-Shift-Enter, and we get the class numeric. So we just created a variable that is of numeric data type. Now, in case you want to create an integer variable, that is a variable of integer data type. Now, this capital L is to indicate that our variable is an integer data type. By default, every number is treated as numeric. So if you want it to be an integer, you have to use a capital L following your number. Okay, so we'll check the data type now. Boom, it's integer now. So we created an integer variable. Awesome. So next step, what is the other data type that we were talking about? Awesome, complex. So to create a complex number, you can do the same thing. A equal to say 5 plus 3i, which is an example of a complex number. Now I can go class A. Whoops. Yeah. Awesome. So we got the output complex. So we created a complex data type variable. Amazing, right? The next in the list is character, which is very basic. So here I'll be creating a character variable. So I have opened and closed step 2 double quotes here, and inside I'll type whatever I want. Now let's check the data type of it or the class of it. Boom, character. Simple, right? Okay, so you have learned about characters. Now the last and final data type that we need to talk about is raw. So what raw basically is how the value is stored internally within the computer. So to do that, let's type a variable name and let it be A, whatever, it doesn't matter. And we type in char to raw, which basically converts a character to raw data type. And inside we type in a character, it can be anything. So say hello, how are you? Now you might ask, what is the difference now? It's just another character or a string, right? Now the difference is when you print out the value. So let's try printing out the value of a by simply typing in a and pressing Ctrl Shift Enter, and boom, you can see the output here. And this is not hello, how are you, but this is the representation of how these characters are stored internally within the computer. Amazing, right? So this is how a raw data type variable is created. Now we can also check the class of it the same way we did before, and we get the class type raw. So we can make use of class to find out which data type our variable belongs to. Awesome. Now if the things were not clear by the previous lecture, now it would make sense, right? So data types are basically how data is represented within your programming language. We learned to create a variable. A variable is basically a name that can hold a value, and we created variables of each of these data types that we learned in the previous lecture. Amazing. So that is all about this lecture. I'll see you in the next lecture where we learn more fun things about R. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about data structures in R. In the previous lecture, we talked about data types, right? Data types deal with what kind of data that we can use in R, okay? So data type is more concerning the different types of data that can be used in R. And that is logical, numeric, integer. We already talked about that. Now data structure is collection of those data. Like it could be a collection of numerics. It could be a collection of integers. It could be a collection of characters. It could be a collection of logical values. So data types are more about what the data is, while data structures deal with how they can be stored together. Okay, so let's talk about the different data structures in R. So the different data structures in R are vectors, lists, matrix or matrices, arrays, data frames, and factors. So these are the 6 main data structures in R. Now R data structures is a pretty big topic. You cannot cover it in one single lecture like we did with data types. So what we'll be doing is that the next section is entirely dedicated to R data structures, because whenever you'll be programming R, you will be definitely making use of one of these. So it's very important to have a very clear understanding of each of these data structures. The next section entirely devoted to R data structures. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So we'll be starting off a new section on R data structures. And the very first lecture is all about vectors. So what are vectors? Vectors are basically a collection of similar type of objects. Now what do I mean by similar type of objects? It basically means that they belong to the same data type. So it can be a collection of characters, it can be a collection of logical values, it can be a collection of integers. Basically, each element must belong to the same data type. It's simple as that. So how can you create a vector in R? I'll show you with a very simple example. First of all, you type in the name of the vector. Let's say I want to make a vector called vehicles. Now, to create a vector, you type in C, follow it up with opening and closing brackets, and inside you type in your elements of your vector, each separated by a comma. So I have a vehicles vector here. So the members will be, say, car, bike, and bus. Awesome. Now if I press Ctrl Shift Enter, if you're on a Mac, you can press Command Shift Enter, and I have my vector created. I can display the values of the vector, car, bike, and bus. Awesome. I can check the class of the vector, and I get character here, which is basically the class of each of the element here. So we have just created our very first vector. Amazing. Now you must be wondering what the C is. To make sense of what C is, there's something that you must know. So in R, there is a priority given for data types, and that priority is logical, integer, double or decimal values, and character. So when you're creating a vector, C, which stands for coerce, checks the data type of each of the element, and it converts all the elements to the highest data type. And that order of data type is basically this. Double is basically decimal numbers, Now imagine instead of car, I had a number here, say 1. So now I can run this here. And you can see that 1, which was basically an integer or a numeric, is now converted to a character. So the order of data types is this: logical, integer, double, and then characters. So if one of your element is a character, that means that that is the largest data type in your vector, and every other element will be converted to character. Now I'll show you another example. Say instead of bike and bus, we had 1.5 and 2. Okay, I know it doesn't make any sense to call this a vehicles vector, but let it be. Now if I run this, you can see that the output now, all of the numbers are now decimal numbers. Now that is basically the job of the C here. It converts all of the elements to the highest data type. And the order of the data types is logical, integer, double, and characters. And in case you still haven't figured out what double just is a representation of decimal point numbers. Awesome. So that is how you make a vector. So to make a vector, all you need to do is type in the name of the vector, an equal to sign, C, and then open and close two brackets, and then type in the elements of the vector, each separated by a comma. Awesome. So that is how you create a vector in R. In the next lecture, we'll talk more about vectors. I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, I'll be talking about different ways in which we can create vectors. So one unique way of creating vectors is using the colon operator. You use the colon operator to create vectors when the value of the vector is a collection of consecutive numbers. So if you want to create a vector that has consecutive numbers in it, you can simply use a colon operator. Now here is an example. Say you wanted to create a vector that had values ranging from 1 to 7. So the starting number is 1, the ending number is 7. So you do this basically, x equals to 1 colon 7. And you get a vector that ranges from 1 to 7. That is 1, 2, 3, 4, 5, 6, and 7. And it gets stored in x. As simple as that. So you basically need to know the starting number and the ending number. And you can generate a vector that has the starting number, the ending number, and all the numbers in between. Simple as that. So here is another example where we had 2, colon, and minus 2. So what this did was that we got a vector that had values ranging from 2 to minus 2. 2, 1, 0, minus 1, and minus 2. As simple as that. So the starting number, the ending number, and the colon operator in between. As simple as that. Now the problem with the colon operator is that these numbers are all consecutive. And when you have to create a vector, that may not always be the case. Another way of generating vectors is using the sequence function. So here is the syntax. We have sequence, opening and closing of brackets, and inside we have these many parameters to fill. So from is basically the beginning of the sequence, to is the end of the sequence. Now by is the range by which each value is incremented, and length is the length of the sequence. Now all of this will make sense with the help of examples. So let's get into that. So if you want to create a sequence that had values from 5 to 10, all you have to do is do this. Sequence 5, 10. So 5 is the starting point, 10 is the ending point, and we get the same output that we would get if we use the colon operator. Now here is the difference between sequence and the colon operator. Say you went like this. Sequence from equal to 0 to equal to 10 and by equal to 2. So what this does is basically you get a vector that has values ranging from 0 to 10, but the difference between the numbers is now 2. So your output is not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's now 0, 2, 4, 6, 8, and 10. That is the difference now is 2. So this is a very easy way of creating vectors, right? So sequence gives you a very wide range of flexibility. Now there was one additional parameter that was there. It was length.out. Now length.out is an alternative to by. Length.out is used when you know the starting point and the ending point, and you know how many numbers should be generated between the starting point and the ending point. So all you have to do is say we have the starting point, which is 0, we have the ending point, which is 20. So imagine you wanted 5 numbers between 0 and 20, then you can simply go length.out equal to 5. And what that does is that you get 5 numbers between 0 and 20. And that is the output here. We got 0, 5, 10, 15, and 20. Now there is one more example. Say we had 1 and 3 and the length.out was 5. Then we got 5 numbers between 1 and 3. That is 1, 1.5, 2, 2.5, and 3. It's simple as that. So you can either use by or you can use length.out to add additional functionality to the sequence function. It's as simple as that. So these are some of the ways in which you can create vectors in R. Now in the next lecture, I'll open up RStudio and implement some of this so that you have a very clear idea about how you can generate vectors in R. Thank you for watching, and I'll see you in the next lecture. Hello and welcome back everyone. So in this lecture, we'll be actually implementing what we learned in the previous lecture. So without wasting further time, the first thing that we learned was the colon operator. So to create a vector using the colon operator, all we have to do is type in the starting point, followed by the colon, the ending point, let's say 8, and Control-Shift-Enter, and poof, we got our vector. Now I can print this out if you want. And we can see that we have a vector that has values ranging from 1 to 8. 1 is our starting point, 8 is our ending point, and we got all the numbers in between them also. Simple as that. Now, as I told you before, this can also be done in reverse order, which basically means you can have a bigger number in the beginning and a smaller number in the end. For example, like this. This also works the same way. You can see that now we got the output 2, 1, 0, -1, and -2, which makes sense. Now the other thing that we learned was using the sequence function. To use the sequence function, you just have to type in seq followed by the starting number and the ending number, say 1 to 8. And we have a sequence that goes from 1 to 8. Simple as that. Now if I want, I can save this into a variable, say x, and then print out x later on. It works the same way. Now we can add additional parameters if wanted. Say we needed to add the by parameter. So we go by equal to 2. Now we can print out x, and we get the output of numbers between 1 and 8, and the difference between the numbers is now 2, which means we got 1 plus 2 3 plus 2 5 plus 2 7. So we can generate sequences in this way also. Now the last thing that we learned was adding an additional parameter called length.out. So what length.out basically does is that it lets you specify the amount of numbers that you need in your sequence between the starting number and the ending number. So say you wanted 4 numbers between 1 and 8, you can go ahead and say length.out equal to 4, and we'll run this, and we'll get 4 numbers between 1 and 8. As simple as that. Now if you wanted 10 numbers between 1 and 8, you can go ahead and make this 10. And we got 10 numbers between 1 and 8. So this is everything that we learned in the previous lecture. Now in the next lecture, we'll be talking more things about vectors. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So far we have been talking about creating vectors. But what is the use of creating vectors if we don't know how to use them? So that is the goal of this lecture. In this lecture, we'll be talking about the different operations that can be performed on our vectors. So starting off, we'll be talking about arithmetic operations, which is basically the same arithmetic operation that you would find in max. So say you wanted to add v and t. You can simply do that by using the plus operator. V plus t, you Control-Shift-Enter, and we got the output 5, 7, and 9. So if you're wondering how we got 5, 7, and 9, it's very simple. What the plus operator does is that it adds the first element of v with the first element of t, the second element of v with the second element of t, the third element of v with third element of t. You got the point. So this is how all the operators work. Now just like the plus operator, you can do the minus operator if you want, and you get -3, -3, and -3. So how we got that is same way as we got the addition output. We subtracted 4 from 1, we subtracted 5 from 2, we subtracted 6 from 3, and the output was -3, -3, and -3. Now the same way you can do the multiplication operator and also the division operator. So the point to remember here is that the output that we are getting is also a vector. So we can actually store it in, say, a variable called result. Say we wanted to multiply the elements of b and t and store it in result. Now I can display the value of result, and I got 4, 10 and 18. 1 into 4, 4, 2 into 5, 10, 3 into 6, 18. You got the point. So this is the way in which we can perform operations on our vectors. So here is a list of arithmetic operators. In case you were wondering, we already covered plus, minus, multiplication. The same way we can perform division, we can find remainders, and we can also find exponents using the caret operator. So if you want, you can try the rest of these operators in RStudio. It's very basic. You just use them the same way we used our plus, minus, and multiplication operators. Now moving on, there is a different type of operators that I would like you to know. They are relational operators. Now the main difference between relational operators and arithmetic operators is that relational operators are used to compare our two vectors. So the output will be either true or false. We won't get a number as output. Now here's a list of relational operators you can see on your screen. Now from this, I'm sure you'll have a very clear idea about how greater than, less than equal to, and greater than equal to work, right? They're just basic math. But what is this double equal to, and what is this exclamation equal to? So the double equal to is basically checking for equality. So it is used to check if two vectors are the same. And the exclamation mark equal to is equivalent to not equal to. So what that means is that we'll be checking if the two vectors are not equal to each other. Now this will make sense when I show you in RStudio. So let's get in there. So like I said, relational operators are used to compare our vectors. Say I wanted to see if v is greater than t. And you can see that the output is a vector of true and false values. In this, we got all of them as false. And why is that? It's because it will check if 1 is greater than 4. No. So we got false. We will check if 2 is greater than 5. No. So we got false again. And we'll check if 3 is greater than 6. We got false again. Now if we want to check if v and t are the same, we can use the double equal to sign. Now if we want to check if v and t have the same values, we can make use of the double equal to operator. And let's see if this works. We got false, false, and false again. Why is that? Because 1 is not equal to 4, 2 is not equal to 5, 3 is not equal to 6. So we got a vector having all the values as false. Now we can check the not equal to operator. And this time, we got the output true, true, and true. It's very obvious, right? 1 is not equal to 4, 2 is not equal to 5, 3 is not equal to 6. So we got the output as false, false, and false. So this is how you make use of operators in R. It's very simple. If you're using an arithmetic operator, the output will be numbers. And if you're using relational operators, your output will be basically true or false values. Now there are some other miscellaneous operators in R, like the colon operator. We already discussed the colon operator when we were talking about creating vectors. We said that we can use the colon operator to create vectors. Say for example 1 colon 4 will give us a vector 1, 2, 3, 4. So there are several other operators in R, but mostly these are the important ones that you need to know for now. Alright, so that is all about some operators in R. I'll see you in the next lecture where we'll talk more things about vectors. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture we'll be talking about accessing vectors. So on your screen I have a vector created A which contains the value 2, 4, 6, 8 and 10. Now what if I wanted to access some specific elements of this vector? So that is the goal of this lecture. So to do that we make use of something called indexing. So indexing is basically done with the help of square brackets. So to access vectors, we type in the vector name, which you can see in this case A, you open and close square brackets, and inside those square brackets you create a vector containing the position of the elements that you want to access. So in this case we need the first 3 elements, so we go in and type 1, 2 and 3 inside this. So what this does, let me run this for you. The output is 2, 4 and 6, which is basically our first, second and third element of our vector. So this is one way in which you can access vectors. Now instead of creating a vector using C inside this, you can also use a colon operator if you want. You can simply go 1 colon 3 which is same as C1, 2, 3, and I get the same output 2, 4 and 6. So to access a vector, you simply have to type in the vector name, open and close two square brackets, inside create a vector containing the position of the elements that you want to access. As simple as that. Now there are two more ways in which you can do this. Now in this case, we specify the position of the elements that we need, right? So we said 1, 2 and 3, give me 1, 2 and 3. Now some cases, you know which ones you don't need. So say you don't want the first element. So how can you access in that way? You can do that by using negative numbers. So here what we do is that inside the vector, we use negative numbers. So say if I went -1 inside that vector, what would happen? Let me run this. I got the output 4, 6, 8 and 10. So what that basically means is that we are excluding the first element. Now if I wanted to exclude the first and the second element, I can go -1 and -2. Now I only have the last three elements. Now if I wanted to exclude the third element, I just need to go -3. You get the point, right? So now we just have 8 and 10. So this is another way of accessing vector elements. You can use negative values to specify the position of the vector that you need to exclude. Now there is one more way in which you can access vectors. It is using Boolean values. So how do you do that? So now I have a vector containing true, false, true, true and false. Now let me run this. Take a look at the output. We got 2, 6 and 8. What does this mean? So how this works is that the first position of the vector contains the value true. So we got the first element of our vector A, 2. The second element of our position vector is false. So basically, when the value is false, you ignore the element or you skip the element or you exclude the element. So when it's true, we include the element. When it's false, we skip the element. So basically, the first element is true. So we got 2. The second was false. So 4 got excluded. Third was true. So we had 6. The fourth is also true. So we have 8. The fifth one is false. So 10 gets excluded. So using Boolean values, you can access vectors. So what did we learn in this lecture? In this lecture, we learned that we can access vectors using square brackets. It is known as indexing. So inside the square brackets, you create a vector containing the positions that you need to access. And the counting of the positions starts from 1. We learned how we can use negative values to exclude certain elements. We also learned how to access vectors using true and false values. So these are basically everything that you need to know about vectors. Now, in the next lecture, we'll be talking about a new data structure called matrix. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about a new data structure called matrix. No, we are not talking about the movie, we're talking about the data structure. You have probably learned what a matrix is in maths, right? So matrix is basically a representation of data in form of rows and columns. A m by n matrix basically means there is m rows and n columns. Simple as that, right? And each element, say if the matrix name is A, A11 indicates the element in the position, first row and first column. A12 refers to the element in first row and second column. So this is how a matrix works in mathematics. Now what is the relation between matrix and data science? In data science, you need to handle a variety of data. So you need to have data structures that can handle these different types of data. And matrix is a very important data structure when it comes to that. So it's very important to learn how you can create a matrix in R. So how can you create a matrix in R? So to create a matrix in R, you have to use the matrix function, which is basically typing in matrix, opening and closing brackets, and then filling in these parameters. Data refers to the elements of the matrix, n row is the number of rows of the matrix, and co refers to the number of columns of the matrix. Now to understand by row and dim names, we have the following examples. First of all, to create a simple matrix, all you need to do is type in matrix, open and close two brackets. Inside, you specify the data, which in this case is specified in the form of a vector, which contains the values 1 to 9. And we have specified the number of rows n row equal to 3, number of columns n col equal to 3. So we got the following output. So we got a matrix having 3 rows and 3 columns with the following elements ranging from 1 to 9. Simple as that. In the second image, you can see that by row equal to true. It's an additional parameter to our matrix function. So what does it do? So basically, by row takes in a Boolean input, and if it's true, then the elements are arranged in a row. You can see the differences in output when by row is true here. 1, 2, 3 no longer is part of the first column. It is now part of the first row. So if by row is true, then the elements are arranged in a row. And by default, if by row is not provided, then R assumes that it's false. So we get the output as shown in the first image. So that is how by row works. Now lastly, what is dim names? Dim names stands for dimension names. What that basically does is that it helps you assign names to your rows and columns. Simple as that. So here's an example. Here we have created two vectors, rows and columns, containing the names of our rows and columns. And then inside the matrix function, we have dim names equal to a list containing both these vectors, rows and columns. And in the output, you can see that now your rows have names. Row 1, row 2, row 3, call 1, call 2, call 3. So we basically named our rows and columns. Now you might be wondering, what is this list? For now, all you need to know is that list is a collection of data structures, and in this case, it's a collection of vectors. The first element is rows, which contains the name of the rows. You can see here row 1, row 2, row 3. And the second element is calls, which contains the names of the columns, call 1, call 2, call 3. So lists help us create a collection of multiple data structures, and here is the collection of row name and column names, and we give it to dim names, which helps us set the names of the rows and columns for our matrix. So we learned about all the parameters of our matrix function. To create a matrix, first of all, you need to have a data. Now this data can be in the form of vectors. nRow specifies the number of rows, ncol specifies the number of columns, by row helps us control the arrangement of these elements, and dim names help us assign names to rows and columns. Now if you want, you can go and open RStudio and try each of these commands to see if it works. In our next lecture, we'll talk about accessing elements of these matrices. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about accessing elements of our matrix. So for that, I have created a matrix M containing the values from 1 to 9, and the number of rows is 3 and the number of columns is also 3. So let me just run this. I'll just print the value, and we got our matrix. Now it has the values from 1 to 9. Simple as that. So how can you access elements of our matrix? Say you wanted the first row and the first column. All you have to do is use indexing, like when we did with vectors. Now here the difference is that you have to specify the row and the column inside these square brackets. Okay? So say you wanted the element in our very first position, which is first column and first row. So the row value becomes 1 and the column value becomes 1. Now let me run this. I got the output 1. Say similarly, you need to access the entire first column. You simply don't provide a row value and just provide the column value, which is 1 in this case. I run this and we got the first column as our output. So this is how you access a matrix. You simply type in the matrix name, open and close two square brackets, and inside you provide the row you want to access and the column you want to access. Now one more thing that you need to know about accessing matrices is using dimension names. So for that, let's create some dimension names. We create a vector called row names containing the name of our rows. Similarly, we create a column vector, call names containing our column names. Now we add a dim names parameter to this, which is basically a list of our row names and column names. Awesome. Let me run this. I'll show you the output. And we have a matrix that has dimension names. So how can you access matrix elements using these dimension names? So now that we have dimension names, we don't have to specify the row number or the column number. We can do exactly what we did with those numbers with names of these rows. So if you want to access the entire row 1, you simply type in row 1 inside quotes and leave the column part empty because we are trying to access the entire row 1. Let me run this and look at the output. I got 147, which is our first row. So instead of using the row number or column number, I can now use the names of our rows and columns to access elements of our matrix. So these are the different ways in which you can access matrix elements. All you need to do is type in the matrix name, open and close two square brackets, and inside you specify the row and the column you need to access. Now this can be either using the names, or instead you can use the row number or the column number. Simple as that. So this is all you need to know about matrices. In our next lecture, we'll learn about a different data structure called data frames. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll learn one of the most important data structures in our data frames. So what are data frames? Data frames is a table or two-dimensional array-like structure. It helps you basically collect data in the form of columns. So each item of the column is of the same type, and each row contains one set of value from each column. Does it sound confusing? Don't worry. I have a very good example that will make it very clear to you. Imagine data frames as your Excel sheets. So basically you have a column called date, which contains all the date, an item which contains all the item, quantity containing quantity, price containing price, etc. right? And each row contains one item from each of the column, and they're all related to each other. This is exactly similar to how data frames work. So how do you create a data frame in R? To create a data frame in R, you type in data.frame, and inside you add in the data that you want to add into your data frame. Now here is a very simple example. Say you need to create a data frame containing two columns, name and age. So first, we create two vectors, name and age, containing those values. Here we have name, which contains House, Castle and Jesse, age containing 50, 38 and 29. Now the point to remember here is that 50 is the age of House, 38 is the age of Castle, and 29 is the age of Jesse. So this data is also dependent with each other. So the goal is to create a data frame containing both of these columns. So all we had to do was type in data.frame, and inside the opening and closing brackets, you type in name, age. And this is how your data frame will look like. You can see that House now has age 50, Castle has 38, and Jesse has 29. And you can see here that R has added an additional column to show you the row number. The first row contains name House and age 50. The second row contains name Castle, age 38. And the third row contains Jesse, age 29. Simple as that. So this is how you create a data frame in R. So in our next lecture, I'll talk about how we can access these values. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll talk about how we can access data frames. So starting off, let's just create a data frame. So we'll have a column or vector called name, having the values as shown in the previous slide. House, Castle and Jesse. We'll have an age column containing the age. It can be anything. And we'll have an additional column called salary. Awesome. So now to create a data frame, like I told you in the previous lecture, I type in data.frame, and then inside I type in the column names. So which is name, age and salary. Simple. And I'll store this in a variable called D. Now let me just print out D so that you can see the output. Awesome. So we have a data frame. Now the next step is to learn how to access it. Now there are two ways in you can access data frames. The first way is using the dollar operator. So basically you type in dollar, and now you can see these drop down lists containing the columns. Say I went in name, D dollar name. Let's run this. Let's see what happens. You can see that I got the entire name column as output. Now I can actually index these. Say I just wanted the first element from this, and I got house as the output, which is basically the first element of the column, right? So this is one way in which you can access data frames using the dollar operator. You can select a column individually using the dollar operator. And if you want to select a specific element from that column, you can then further index it. Now another way of accessing data frames is using the proper indexing that we learned when we were talking about matrices. Say you just want the first row. You simply type in 1, comma. And we can see that we got the first row as our output. Now we can collectively select multiple rows using C. Say you wanted 1 and 2. That is the first and the second row. We do this and we get the first and the second row. Simple as that. Now, another interesting thing to know here is that when you're accessing these data frames, it also helps you manipulate their values. Say you wanted to modify your salary, right? You want to change the salary of your data frame. You want to divide each of those salary values by 10. You can actually do that by these methods that we just learned now. So to do that, first of all, we select $salary equals, because we are changing the salary value, $salary divided by 10. Let me just run that. I'll print the value of D entirely. And you can see that the salary values are now divided by 10. They are no longer 10,000, 20,000, 30,000. They are now 1,000, 2,000, and 3,000. So this is the main goal of learning to access these data structures so that you can collectively manipulate them in a very easy manner. Now, another interesting thing to learn about data frames is that there is a function called summary which allows you to get a summary of your data frames. So let's get a summary of D. So to get that, you just type in summary, open and close two brackets, type in D inside. Let me just run this for you. And you can see that I got a summary of our data frame containing the minimum value, the median value, the mean value, the first quartile value, the third quartile value, the maximum value. I get a lot of information about my data frame using the summary function. So summary is a very handy function in case you want to find out some information about your data frame. Alright, so that is all about this lecture. We learned a lot of fun things about data frames. We learned how to create data frame. We learned how to access data frames. So thank you for watching. I'll see you in the next lecture. Hello and welcome back everyone. In this lecture, we'll be learning a new data structure called arrays. So what are arrays? Arrays are basically multi-dimensional collection of elements having the same data type. So what does that even mean? Think of arrays as a combination of everything that we learned in vectors and matrices. So to create an array, the first step is to type in array, open and close two brackets, and then we have to provide these parameters. Data, which is the data that will be stored inside the array. Dim is a parameter used to represent the dimensions of our array, and dim names is used to provide the names for these dimensions. Now all of this will make sense when I show you an example. So here's a simple array that I have created in RStudio. So to create the array, I typed in array, open and close two brackets, and inside I specify the parameters data and dim. So the data of the array is basically three words, who, are, and you, and it is entered in the form of a vector here, as you can see, and dimensions is also specified as a vector. So what does all of this mean? So to understand this, we have to understand the dim parameter. You can see that the first value of the dim parameter is 3. This 3 represents the 3 rows, right? You can see that we have 3 rows here, so that is represented by this 3. The second value of the dim vector is basically another 3, which represents the number of columns. You can see that there are 3 columns, right? And what's new here is that there is an additional value, 2, which represents the levels of our array, which means that when you specify here 2, what actually happens is that we get 2 matrices containing 3 rows and 3 columns. If this was 5 instead of 2, then we would have had 5 matrices that had 3 rows, 3 columns containing the values who, are, and you. So this is how an array works. Now one of the most key things to remember here is the fact that arrays will always have the same data type values, right? So here all the values are of character data type. You cannot mix data types. So it's very much similar to what we learned in vectors, and the representation of it is similar to that we learned when it came to matrices. So this is a very good way of looking at arrays. So if you have a clear idea of how a vector and a matrix works, then arrays is very simple, right? Awesome. So another thing that we learned in our previous slide was that there is an additional parameter called dim names, which can be used to give dimension names to your arrays. So here's an example for that. We create a vector called row names containing the row names. We create a vector called col names containing the column names. We create a vector containing matrix names, because this time we also have to name our matrices containing M1 and M2. Simple as that. And inside we already have our data, we already have a dimension. Now we had our dimension names parameter, dim names, and it is a list containing row names, column names, and matrix names. It is very similar to the case of matrices. The only difference is that now we have an additional value called matrix names, because we also have to name not just the rows and columns, but also the matrices. And here is a representation of the output. R1, R2, R3 represent the rows, C1, C2, C3 represent the columns, and M1 and M2 represent the matrices. So this is how you add dimension names to your arrays. In the next lecture, I'll open up RStudio, create an array, and show you how we can access the elements of the array. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about accessing array elements. Starting off, I have created a vector called row names containing the row names, call names containing the call names, matrix name containing the matrix names, and then I created an array and stored it into the variable a. Now the value of the array is the same as you've probably seen in the previous lecture. So let me just run this for you. Awesome. I'm just going to print out a so that you have an idea how it looks. And this is our array a. Now accessing elements of the array is very much simple. It's basically indexing that you learned when it came to vectors and matrices with a slight twist. So starting off to access array elements, you type in the array name and then open and close your brackets. And then inside, you specify the row number, let's say 1. You specify the column number. Now the twist part is, you also have to specify the matrix number. So here there are two matrices. So let's say from the first matrix. So this is how you access elements of an array. So instead of specifying just the row and the column when it came to matrices, instead of just specifying the element position when it comes to vectors, when it comes to arrays, you have to specify the row number, the column number, and also the number of the matrix. Simple as that. That is the only difference. Now I'll just run this for you, and we got who, which is basically the desired output. I can skip parts. Let's say for example, I can skip the matrix part, and then I'll get the output from both the matrices, who and who. I can skip the column also if I wanted to. Then I'll get the first row, every single column from every single matrix. And look at that. Simple as that. Now, just like with matrices, you can actually replace the row number, column number, matrix number with row names, column names, and matrix names. Say for example, instead of 1, I could simply go R1 and run this, and I get the same output. So this is how you access your array elements. Alright, I'll see you in the next lecture. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about lists. Now list is not a new concept. I already introduced you to list in some previous lectures where we had to make use of it while naming our certain parts of our data structures. So this lecture is devoted purely to lists as a concept. So what are lists? Basically until now we learned a lot of data structures. We learned about vectors, we learned about data frames, matrices, arrays, and a lot of data structures. So what list does is that it helps you combine everything that you have learned into one single data structure, which basically means is that you can have a collection of every other data structure that you learned till now as a list. So what I mean to say is that you can take a look at the example in your screen. We have made a list containing a string red, a vector C 1 2 3, a boolean value true, a matrix, an array, and all of this is stored into a variable called things. So this is how we make use of list in our programming. So basically what lists are is that it is a collection of data, and that can be anything. It can be strings, it can be vectors, it can be boolean values, it can be other data structures. It is a collection of all these things together. So this is what basically a list is. In our next lecture, I'll talk about our last and final data structure called factors, and then we'll get into the practical stuff. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. In this lecture, we'll be talking about our final data structure, factors. So what are factors and why do we need them? So I have created a vector here called gender containing the values male and female. Now when you're programming, especially when you're handling data science problems, you'll have to handle a lot of text data or string data. Now the problem with string data or text data is that they are very memory intensive because there's a lot of characters to store, right? So this problem is solved by factors. So what factor does is that basically it encodes strings into numbers. So instead of storing the whole string, you just have to store the number. So in this case, male contains 4 characters, M, A, L, and E. So we'll just give it a number 1 or 2, for example, and instead of storing those characters, we just have to store the number, which is a lot less memory intensive. And this can easily help us optimize our algorithms. So let me show you how we can create a factor. So I'm going to create a variable factor gender here to store the factor version of our gender data. So to create a factor, all you need to do is type in factor, open and close two brackets, and then inside you give in the data. In this case, it's a vector gender containing the values male and female. Now let me run this. Now to get a clear idea of what happened here, I'm going to use the structure function str and then pass in factor gender inside. Now let me run this. We can see that the output is factor with two levels, female and male. So instead of storing 4 characters for male, we just have to store the number 1. And when number 1 is used, we know that it is male. So basically we are just encoding our strings into numbers so that the memory consumption is a lot less. So this is how factors are used in our programming. They basically help us encode our strings to reduce its memory consumption. As simple as that. So these are all the data structures that you need to know in R. We have covered all the basics that you need to know. From here, we'll get our hands dirty by going into practical stuff. So we'll make use of everything that we learned till now to solve practical problems in our next section. So I'll see you there. Thanks for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, I'll talk about assignment operators in R. How do we normally assign values to variables? We use the equal to operator. Now, if you're referring to other courses, maybe other books, or maybe any other tutorial on the internet, they might be using this arrow operator for assigning values to variables. You see this arrow operator, right? Both of these mean the same thing in R, right? There is a very minute difference between the equal to and the arrow operator for assigning values, and I'll get to that. But if you're referring to any other tutorial or maybe some other course on R programming, you might find them using this. Now I want you to know that 99% of the time, both of these mean the same thing, and it's mostly preference. Now some documentation or guides on R recommend that you use the arrow operator because it's just a programming style. Now I like to use the normal equal to assignment operator because first of all, it's easy to understand. If you're a beginner, you can simply look at x equal to 5 and make sense out of it. And second of all, every other programming language, like every major programming language like Python, C, C++, Java, whatever you take, they all use equal to, right? So if you have previous programming experience, it makes a lot more sense to use equal to. Now, I'm not saying using the arrow operator is bad or something. It's just preference. And also, they're not entirely the same. I'll be using the mean function call to show the difference between equal to and the arrow operator. Say I had to find the mean of a vector x containing values 1 to 10. I'll run this. And I got the output 5.5. I'll just clear the console and run this again. Awesome. Okay, so I got the output 5.5. Now, imagine me trying to print the value of x after this. Now see that x is created inside these brackets. What I mean by that is that x is created inside the function call. So the scope or the accessibility of the x variable is limited within this function call. What I mean by that is that we cannot use x outside this function call. Say if I went and typed in x here and tried to run it, I would get object x not found because this x is defined within this function call and it cannot be accessed outside it. Everything that is written outside functions and function calls is known as global variables. Now what do I mean by global variables? Global variables are those variables that can be accessed from anywhere in the program. Now there is a very specific programming term for it. It's called scope. Alright? So scope is something that refers to the place where something can be used. Alright? In programming terms, it is the place where you can actually use your variable that you created. Say for example, we created x and this x is only accessible inside this function call and not outside it. Now if you have any previous programming experience, I'm sure that you guys already know about scope. Now the major difference between equal to and the arrow operator is that suppose I use the arrow operator here. Let me run this. You can see that x got added to our global environment variable list. So what I mean by that is that now I can type in x outside the function call and it would work. So this is the difference between the arrow operator and the equal to operator. When you use arrow operator, it becomes a global environment variable, and when you use equal to, it is limited to that particular scope. Now, when we are doing this outside function calls, right? When we are doing this like x equal to 10, x arrow 10, These mean the same thing. There is absolutely no difference. The only difference is when they are used within function calls. And throughout this course, we'll be using the equal to operator as our assignment operator for reasons I already mentioned. Alright, so that is all about this lecture. Thank you for watching and have a wonderful day. Hello and welcome back everyone. From here on, the style of our lectures is going to change. Everything from now is all practical and real-world applications using R. Now there are so many courses out there that teach you all the theory, but they don't teach you anything about real-world stuff. You will complete the course, you will have an understanding of everything that they teach, but you won't be able to do anything on your own. So that is the goal of the upcoming sections, to give you an understanding of the practical and real-world use cases of everything that you learn until now in this course. So starting off, what I planned is that there will be 4 sessions at least, and maybe on later I'll feel like adding some more. I'll start off with data preparation, which involves getting data sets from the internet and then converting them into a form which can be used later on, like extracting information from that data set. That is our first session. And in our next section, we'll talk about visualization. Now, visualization involves viewing the data in form of charts and graphs so that you have a better understanding of what the data is trying to tell you. And you can find patterns that you can make use of to build practical applications. In the next 2 sections, I'll be talking about machine learning and how we can apply machine learning algorithms on our data set to come up with real-world solutions. So starting off, the number one thing that we need to do is to find a data set. Now there are so many data sets available on Google. You can just go data science data sets on Google and you'll find links from Kaggle, you'll find links from DataQuest and so many websites. And you can see that in Kaggle they are made available a lot of public data sets that you can download and make use of. But for these sections, I'll be using the very popular Iris dataset. Now if I just Google Iris dataset, I'll find this Iris dataset from UCI Machine Learning repository, and I'll be using that for all our sessions. Now a little bit more about this dataset. So our dataset contains all these physical information: sepal length, sepal width, petal length and petal width, along with which class of iris these particular data belongs to. Right? So now before you get into these sections, one thing that I want you to know is that I won't be able to teach you everything that is there about R and data science. But what I aim to do is to give you a foundation on which you can build upon and learn things on your own. So that is the goal of the upcoming sections. You have to try and experiment things on your own. That's the only way in which you will learn. So without wasting any more time, let's get to the real stuff. So I'll see you in the next lecture where we start learning practical applications of R. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So we are going to be starting off our practical data science section by learning how we can import our dataset into our programs. Now there are several ways in which you can do this, and when you look at different tutorials you might find different ways, but these are the most common ways in which you can do it. Starting off, in the previous lecture I showed you this website that contained the Iris dataset. You can simply get this by googling Iris dataset, and if you click on the data folder here, it will take you to this page. Now what I want to do is that this iris.data link that you can see here is actually our dataset. So what I'm going to do is the first method of importing dataset into the program is getting it from links. So one way of doing that is simply by right clicking this iris.data file and copy link location. I can click on copy link location to get the link, and then I have stored that value into a variable in the program, as you can see here, and I have stored it as a string. So this is actually this same link. Like, I'll just paste it here so that you get an idea. Yeah, so we pasted this link and stored this into a variable link. Alright, so the next step is to actually import the dataset from this link into our program. So I'll create a variable iris. Now I'll go in and type read.csv, and then I use a URL function. Now this function is used when we are dealing with the links, and now I add an additional parameter to read.csv saying header equals to false. Now what is this header equal to false? Now in some datasets, the first row might contain the column names or the headers. Say for example, in this case, it can contain headers like petal length, petal width, sepal width, etc. And you don't want those headers in your actual data set because you just want the values, right? So if that is the case, then you can give header equal to false. Alright, now let me just run this. And you can see that there are no errors. Now I'm going to try and actually view this data set by using the view function. Now note that the V here is capital. I type in view, open and close two brackets, and then I type in iris. So what this view function does is that it helps us view our data set. Now let me run this. And you can see that we got a separate tab containing the values of our data set. There are 150 rows and 5 columns where each column represents a particular attribute of our data set. Simple as that. So this is one way in which you can do it. Now another way of doing it is using packages or libraries. Now in your RStudio you can find this tab called packages. Now in packages there are several packages available here, as you can see. Now the goal of these packages and libraries is to simplify our programming. Like they have some inbuilt functions and data values which you can use to simplify your programming process. That is the main goal of packages and libraries. For example, if you have something that takes 10 lines of code to do it, there might be a library or a package that simplifies it and does that work for you. So code reusability and simplifying things is the goal of packages and libraries. And in this particular case, there is a package or a library called datasets. To find it, you can just simply type in datasets in the search bar and you can select this, and RStudio will import datasets into our program. So datasets is a dataset package. It contains a lot of datasets, including the iris dataset. So once I have imported it by checking this checkbox, I can simply go ahead and type in iris, and RStudio will identify iris as a actual variable. Now if I run this, I'll actually get back the entire iris dataset. Now the last method is very simple. You can easily do it because we already covered it once. You just have to go and download the dataset and then provide that location inside read.csv, and you will have the dataset imported into your program. Now this is something that we had done in previous lectures. If you remember, if you go back to the last section, there was a lecture that was there for this very purpose. It will help you import CSV files locally by providing the location of that file into read.csv. So if you don't remember that, you can go back and revisit that lecture, and I want you to try doing it on your own. Now remember, the only way in which you can get better at this is to actually try this on your own. So please do try it on your own so that you can also learn as we go. So this was the very first step in data preparation. We learned how to import data sets into our program. So that's all for this lecture. I'll see you in the next lecture. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about data preparation. In the previous lecture, I told you that we can import data sets into a program. And here, as you can see, I have imported the iris dataset with the help of datasets package that I have imported here, as you can see. So when I type in iris, I actually get a data frame containing all the iris data. Simple as that. Now I can just run this if you want, and you can see that I get the iris dataset. Simple. Now, we have successfully imported dataset into the program. Now, let's study the dataset. So one of the most basic things that you can do is to actually find the dimension of your dataset. Now what do I mean by dimensions? Dimensions are basically the number of rows and the number of columns. So I could either print out the dataset and observe it from there, or I could simply go in and type in DIM and then followed by the dataset name, and I get the output 155. Now 150 is basically the row number and 5 is the column number. So this is how you can find dimensions of your dataset. Or another way is just to print out and then observe from the output. You can simply see that there are 150 rows, and if you scroll up you can find the columns. Now this is the case of the iris dataset. Now sometimes when you're using your own datasets or when you're downloading it from somewhere on the internet, it might not have any column names, or it might not have the column names that you want. Alright, so it's important to add column names to your dataset. So how can you do that? Here you can see that it's already there, but in case you are having a dataset that doesn't have any column names, or you want to change these existing column names, you can make use of this method that I'm going to show you right now. So to add column names, you simply type in col names and then type in the data frame name, which is iris. Now I have to give this a value, and that value is given in the form of a vector. So I typed in C and created a vector containing our custom column names. Now I'll run this. Now let's print out our data set. I'll use view this time. And you can see that we have our data set, and you can see that the column names have changed to our custom names that we have provided here. Alright, so we have started learning about data preparation, and in this lecture we learned about how we can find dimensions, and we learned how we can add column names. I'll see you in the next lecture where we talk more about data preparation. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll be talking about missing values. Now the iris dataset is a perfect dataset. There are no missing values in it. But that is not always the case when you're importing dataset from the internet or your own dataset. There are chances that there might be missing values. Now missing values in R is denoted by NA. So how can we check for missing values in a program? Whenever you want to check something in R, for example, if you want to check if something is an array or a data frame, you type in ease and follow it with the dot operator. And you get a list of things that you can check, right? Now you can check if something is an array, a data frame. There are a lot of things that you can check. Now here, we'll check if there are NA values. So you do that by typing in ease.na, and then I'll type in the iris dataset. And we already know that there are no missing values in our iris dataset, but I'll just do it. You can see that every entry is now false. Now false indicates that the value is not NA. Now looking at this large data set and trying to see if there is any true value in it is very difficult, right? So to simplify the process, there is a function called any that does this work for us. It basically checks the entire data set if any of the entries are true. And if one of the entries is true, then we'll get the output as true. Here, since all the entries are false, we get the output as false. Now instead of any, we can use sum to get the total number of NA values in our dataset. Here in this case though, it is 0 because there are no missing values. The iris dataset here is perfect. But what if your dataset contains missing values? How can you handle it? So to address that issue, I have created a data frame containing 2 missing values. Here you can see that in the second column there are 2 missing values. So now let's apply what we just learned on this data frame. So the first thing that we did was we typed in ease.na, and then I typed in df, and now you can see that in the output section the third and fourth row second column now contains 2 true values because those values are actually NA. Now I can apply any on it, and you can see that I got a common output true because some of the values are missing, and I can replace any with some, and what would happen? You'll get the output 2 because there are 2 missing values. Simple as that. So this is how we can identify missing values in our dataset. Now in the next lecture, I'll talk about how we can solve this issue. So thank you for watching. I'll see you there. Bye. Hello and welcome back everyone. So in this lecture, we'll be talking about missing values. Now the iris dataset is a perfect dataset. There are no missing values in it. But that is not always the case when you're importing dataset from the internet or your own dataset. There are chances that there might be missing values. Now missing values in R is denoted by NA. So how can we check for missing values in a program? Whenever you want to check something in R, for example, if you want to check if something is an array or a data frame, you type in ease and follow it with the dot operator. And you get a list of things that you can check, right? Now you can check if something is an array, a data frame. There are a lot of things that you can check. Now here, we'll check if there are NA values. So you do that by typing in ease.na, and then I'll type in the iris dataset. And we already know that there are no missing values in our iris dataset, but I'll just do it. You can see that every entry is now false. Now false indicates that the value is not NA. Now looking at this large dataset and trying to see if there is any true value in it is very difficult, right? So to simplify the process, there is a function called any that does this work for us. It basically checks the entire data set if any of the entries are true. And if one of the entries is true, then we'll get the output as true. Here, since all the entries are false, we get the output as false. Now instead of any, we can use sum to get the total number of NA values in our data set. Here in this case though, it is 0 because there are no missing values. The iris dataset here is perfect. But what if your dataset contains missing values? How can you handle it? So to address that issue, I have created a data frame containing two missing values. Here you can see that in the second column there are two missing values. So now let's apply what we just learned on this data frame. So the first thing that we did was we typed in ease.na and then I typed in df. And now you can see that in the output section, the third and fourth row, second column, now contains two true values because those values are actually NA. Now I can apply any on it. And you can see that I got a common output true because some of the values are missing. And I can replace any with some. And what would happen? You'll get the output 2 because there are two missing values. Simple as that. So this is how we can identify missing values in our dataset. Now in the next lecture, I'll talk about how we can solve this issue. So thank you for watching. I'll see you there. Bye. Hello and welcome back everyone. So in this section, we'll be talking about visualizing our data in R. So the first thing we need to ensure is that we have all the packages required for this. Now there are several packages that can help you visualize your data in R. In this section, or in this course, we'll be using the most standard package of them all, which is the graphics package of R. Now there are several other packages other than the graphics package which will help you visualize data, but in this course we'll be focusing mainly on the graphics package. And once you understand the graphics package, you can take in any library you want and you can just simply read the documentation and it will make sense to you. The best part about R programming is that once you clear the basics, then you can learn anything on your own. So that is the whole point of this course. I'm not going to be able to teach you everything that is out there, but if I can teach you the basics of everything, then everything else you can just pick it up on your own. So that is the main goal of this course and of this section. So we'll start with visualization, and the first thing you need to ensure is that you have imported the graphics library. You can do that by simply searching graphics in this search box, and you can see the graphics in the list here, and you can simply select this checkbox and you will have graphics library imported into your program. Alright, so now the next thing you need to know is that there are several graphs that you can use for visualization. You can simply use a scatter plot, you can use box plot, you can use histograms. There are several statistical representations of data. And I'll be covering the most commonly used graphs in this section. And we'll be using the iris dataset. Alright, so that is an introduction to this section. So in the next lecture, I'll start visualization using the graphics package. I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. Now, whenever you want to learn a package, the first thing you should do is to simply take in your browser and type in R documentation. Now this will take you to the official page. The first link is rdocumentation.org. Now this is the official R documentation page. So any package you want to learn, you can simply search here and you'll find a detailed explanation on how you can use it. So here, now, we have to use the graphics package. So you type in graphics in here. Alright, now you can see the latest version is this, 3.6.1 of our graphics package. We'll click on it. And now we get a list of functions that comes with the graphics package. So if you want to make use of any of these functions, you just have to simply click on it and there will be a detailed guide on how you can use it. Now I'm showing you this because the next time you want to learn a package, this is what you have to do. You go to the official documentation page, you search the package, and then you read the documentation and you'll be able to make use of it. Okay, so now our graphics package contains a lot of functions. I'll be teaching you the main ones. So starting off, the most important function in the graphics package is the plot function. So let me just find plot from this list. Here, plot function. I'll click on plot and I'll get a detailed explanation on what plot is. Now plot is used for dot plots or scatter plots. So I'll show you a simple example. Let me create two vectors, 1, 2, 3, 4, y, 1, 2, 3, 4. Now I'll plot this by typing in plot x, y. And this is my result. I got a simple dot plot containing x and y. Now x is used as the x-axis, y is used as the y-axis. Simple as that. So we got a dot plot. Now, to learn more about the plot function, we can take a look at the documentation. Now the documentation says that the plot function contains x values, y values, and then it contains an additional parameter called type, main, sub, xlab, ylab, asp. Now, there is also a definition of what these parameters are right next to it. So starting off type. Type is basically controls the type of the plot. So what do I mean by that? So let's learn this by trial and error method. Simply, it says that type equal to L will replace the points with lines. So let's try that. So I'll add an additional parameter, type equals to L. Now, you can observe a plot. It's that our points are now connected with a line. So this is the goal of type equal to L. Now, there are several other types like these. We can basically have S for stair steps. Let's try that one also. So instead of a straight line, now we have step like plot. So these are the different types that you can have. There are several of them. You can try each of them if you want. Now let's move on to the next parameter. The next one is main. So what main does is basically it gives a title to your graph. I'll show you how it works. Main equals, I'll say graph. Let me run this, and you can see that now we have a heading saying graph. So main is basically used to give title to your graph or plot, whatever you like to call it. Now let's take a look at the next parameter. Sub is for subtitle. You can just try that on your own. Xlab and Ylab are basically to add labels. So here you can see that the label is by default X and here it's by default Y. If you want to change that, you can add your own labels by simply going xlab equals to, this is X. I'm just going to give something random. I know this doesn't make any sense. I'm just showing you so that you get an idea of how it works. Now you can see that the labels have changed to what we have provided here inside the parameters. Now the last thing we can do is that the Y value of this plot function is optional. You can actually skip it. You can simply go X and we can just not provide a Y value. So in case the Y value is not provided, RStudio treats the X values as the Y values. So that is how the plot remains the same. Now before we close off this lecture, we can similarly plot the iris dataset. Now if I simply went plot iris, it would plot every column of our iris dataset. You can see that we got every column of our iris dataset. Now if we wanted to individually plot a specific column, I can simply use the $sign and then select it. So here I'm plotting the sepal length and I got a dot plot of or scatter plot of a sepal length. Now just like this I can plot sepal width if I want. You get the point. So this is how we can use plot function. So to learn more about plot function, you simply take the documentation and then you can experiment with different values for each parameters. The only way you learn these things is by practice. So make sure that you are actually making use of this section to practice visualization by taking the documentation and trying things on your own. Alright, so this was about the plot function and the scatter plots. So in the next lecture, we'll talk about more graphical representations. I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back everyone. In our previous lecture, we talked about scatter plots, and in this lecture, we'll talk about a new graphical representation, and it is going to be bar plots. So I'll go back to the documentation page and find bar plot. Okay, so this is bar plot. Now bar plot is basically, instead of having a point representation, we will have a vertical or a horizontal bar that represents our data. So just like in the case of plot, there are several parameters here, alright? And instead of X and Y, we'll be providing the height and the width of our bars, and along with several other parameters. Now I'm not just going to cover all these parameters. It will take forever if I cover all of them. You can just simply read the documentation and figure it out on your own, but I'll just show you how you can make one. So the first step is to replace the plot function with bar plot, and I'll be using the width dataset. I'll just run this, and you can see that I got a simple bar plot. Now there are several parameters that you can use here, but one I would like to show you is the color parameter. Now color parameter is used to give color to your data. Now one such example would be to just maybe, now the name of the color is provided in double quotes as a string. I'll use green color here, and you can see that the color of the plot now changed to green. If I wanted it to be red, I'll just change this to red, and now I have it in red. So this is how bar plots are created in RStudio. You simply type in bar plot, open and close two brackets. Inside you provide the height, The first parameter is basically the height, and then you provide additional parameters like maybe width, space, name.argument. There are several things here that you can use. You can try this by taking this documentation page and experiment with different values. Now I'd like to show you guys one more parameter. Another very useful parameter amongst this huge list is basically the Horace parameter. So what the Horace parameter basically does is that it helps us change the orientation of our plot. So if I changed Horace equals to false, I'll get the same plot. If I made it true, you can see that our plot now flipped. It is horizontal instead of vertical. So if this is false, the plot will become vertical, and if this is true, our plot will be horizontal. So this is also another parameter that you can make use of. Now just like this, there are several other parameters that you can try. So I want you guys to go to this documentation page and try different parameters on your own. If you come up with any questions, any doubts, you can simply go to the discussion section and ask your question. I'll clear them as fast as I can. Alright, so this was about bar plots. In the next lecture, I'll show you a different visualization technique. So thank you for watching. I'll see you there. Bye. Hello and welcome back everyone. In this lecture, we'll talk about more visualization functions that come along with the graphics package. One such important one is box plot. So before we plot a box plot, first I want you guys to know what a box plot is. So what is a box plot? Now, there is a beautiful article in towardsdatascience.com containing everything we need to know about box plots. So basically, this is the shape of a box plot. There is a minimum value, there is a maximum value, there is a median value. Q1 represents the values that are between the minimum value and the median value, and Q3 represents the value that is between median value and the maximum value. And these outliers are data points that do not belong in this data set. So box plot is basically used to give you all these statistical information in a very effective manner. So this is basically a straightforward explanation to what a box plot is. I will link this article to you so that you can read it for more information in case you want to know more. But the point of this lecture is to actually plot this in R. So to create a box plot, all I have to do is just type in box plot, and inside the brackets I had to provide the data. Basically here I have used the iris sepal.width data, and the color is red. Now let me run this, and you can see that this is a box plot. So this is how you create a box plot in R. Now there are several other parameters that you can use, that you can just go back to the documentation and refer to it in case you want to add some additional parameters to this. So that is all about box plots. I'll see you in the next lecture where we learn more about visualization functions. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll talk about more visualization methods. And one of the most important visualization methods is histograms. So how can you plot a histogram in R? All you have to do is replace this box plot function with hist. Now let me run this, and voila, we got a histogram. So what is a histogram in case you're wondering? Basically, histogram contains an x-axis and a y-axis. The y-axis contains the frequency, x-axis contains data values. So what do I mean by that? By frequency, what I mean is, say for example here, our data set contains values ranging from 2 to 4, alright? And the y-axis is the frequency. By frequency, I mean the number of times these values are occurring in our data set. So just by observing this graph, I can say that the value 2 occurs around 4 times approximately. So that is basically what a histogram is. Just by observing this histogram, we can see that the frequency is very high for values between 2.5 and 3. So just by plotting this histogram, we can come to a conclusion that the iris sepal.width values are mostly ranging between 2.5 and 3. So just by plotting a histogram, we got a very interesting observation about our data set. So basically this is the goal of visualization. It can help you find patterns that you cannot see just by looking at the numbers. Maybe you can see it looking at the numbers, but this just makes it easier. So that is the goal of visualization, and that is what I want to show you guys through this section. Now there are several other visualization functions. You can see here there are so many, and this is just the graphics package. There are several other packages in R that will help you do the same thing. So if I had to cover all those, it will take forever. But my goal is to introduce you to these things and show you how you can learn it. So the next time you want to learn a package, please go to the documentation page, search for the package, find the functions that comes with the package, and then try it. There is no easier way to learn this other than trying it on your own. So this is the end of our visualization session. I hope it was interesting and I hope that you guys learned something from it. Now, if you have any doubt about any concept that we have covered till now, please drop in by the discussion section and I'll help you in any way I can. So thank you for watching and have a wonderful day. I'll see you in the next lecture. Hello and welcome back everyone. So we are going to start our new section on machine learning. Machine learning is a very huge topic and is one of the most hottest fields in computer science today. But remember, I cannot teach you everything that is there about machine learning in one section. So the only reason that I've decided to include this into this course is because if you're planning to continue studying data science and get into more intermediate and expert level topics, you will at some point have to learn machine learning. So it would be unfair to teach you guys an introductory course on data science without introducing you to machine learning. Also, I don't want you guys to leave this course without making a real life project. I want you guys to feel as if you actually made something that is practical. So that is the reason why I have decided to include machine learning into this course. But at the same time, I want you guys to remember that this is just going to be a subtle introduction. Machine learning is a huge topic and I'm just going to introduce you to the surface of it. Okay, so let's get started. First of all, what is machine learning? Imagine someone asked you to write an algorithm to add two numbers. This is the way in which you will do it, right? You will read the x value, x just indicates the first number. You'll read the y value, which is the second number. Then you will add those and store it into a variable, sum, and then you'll print it, right? The variable name can be anything, it's just random, right? Just consider this example. This is how you do traditional programming, right? You write an algorithm, then you apply some data on it, and then you get the output. Simple. But what if someone asked you to write an algorithm to detect cancer given the healthcare data? You can't simply go and type read x, read y, and then just perform some mathematical operation and then come with a solution. It doesn't work that way. Also, the dataset is huge, and optimizing such an algorithm will be a huge trouble. So, we had to find a way in which we can solve this issue of handling huge data sets and complex problems. And that is the reason why machine learning came into existence. Now in machine learning, what happens is you don't write an algorithm. You feed the computer with input and output values. Now these are sample input and output values. So instead of writing an algorithm that adds numbers, we will feed the computer with data. For example, look at the table here. When x is 5 and y is 6, we say that the sum is 11. When x is 10 and y is 20, we say the sum is 30. Now similarly, we feed the computer with a lot of input and output samples, and then our computer comes up with an algorithm on its own. I'm taking this small example so that you guys have a very clear idea of how machine learning works. I don't want to teach this with a very complex example. Now in machine learning, what we do is instead of writing an algorithm to add two numbers, we'll feed the machine or the computer, whatever you like to call it, with input and output samples. Alright? Say for example this table, x and y, and then sum for that x and y. So the computer, by analyzing all these data, it comes up with its own algorithm. Now remember, I'm just taking a very simple example of addition. The real world machine learning problems are much more complex than this. I just want you guys to understand the concept. So in machine learning, the computer comes up with its own algorithm. So we are teaching the computer to learn like human beings, and hence the term machine learning. Now to make this more clear, let's take a look at this diagram. So in traditional programming, we feed the computer with data and the program. So computer uses the data on the program or algorithm or whatever you like to call it, and then gives us an output. In machine learning, what happens is we give the computer data along with output corresponding to that data, and then computer comes up with its own program or algorithm which we can use on new data to predict the outputs for those new data. So we're using pre-existing data and the corresponding output to train the computer to create a model or program or whatever you like to call it that we can use to predict the output of new input values. Okay, so we train the computer with values that we already know, and then we create a model that we can use to predict the output of our new input. So I want you guys to maybe revisit this lecture if it's not very clear, because it's a very complex topic and I'm trying to make it as easy as it can. Okay, so machine learning is us teaching the machines to learn by giving it some sample input and output values, and then we will train the computer based on those input and output values, and we'll create something called as a machine learning model. And then we will give it new input values, and the model will try and predict the output value. So this is how machine learning works, and I hope the introduction is clear. It's a very complex topic, but I hope the introduction is clear. If it's not, please drop in by the discussions and I'll help you. Okay, so that was the introduction to machine learning. I'll see you in the next lecture where we'll talk more about it. Thank you for watching and have a wonderful day. Hello and welcome back, everyone. So what are we making in this section? In this section, we'll be making a machine learning model that can predict sepal width given the value of sepal length. Now, isn't that interesting? Yes. Now, before we start, I want you guys to remember this one more time. Machine learning is a huge topic, and the goal of this section is not to learn that, because it's impossible to cover machine learning in a section. Our goal is to make a practical project, right? And to revise everything that we learned in this course, right? So that is our goal, and without wasting further time, let's get started. So I have opened up our studio here, all right? These are the 5 steps to build a machine learning model that can predict sepal width given sepal length. So the first step is basically to load the data set. Now the data set that we'll be using is the iris data set. So as shown in our previous lectures, we just have to simply go and find data sets and make sure that it is selected. So that part is done. And to ensure that it is there, we'll just view the iris data set. Awesome. So we have successfully imported our iris data set. Now the next step is to pre-process the data set. Now what do I mean by pre-process? In this case, we are dealing with sepal length and sepal width, right? So we need to isolate these values. So how do you do it? We do it with the help of indexing that we learned in our previous sections. And what I want to do is I want to print out the sepal width value, and you can see that now we got a variable sepal width containing all the sepal width values. So we basically isolated the sepal width values from our iris data set. Now the same way we will isolate the sepal length value. Just print this one out for you. So these are our sepal length values. Amazing, right? So we basically pre-processed our data set by extracting the information that we need. We got sepal width and sepal length from our iris data set. Awesome. Now let's visualize it. To visualize it, we simply have to use the plot function, and we'll go sepal length, sepal width. Awesome. So this is how you can visualize our data. We learned about this in our previous sections, right? We use the plot function to visualize our data set, and the x-axis is sepal length, the y-axis is sepal width. So we completed our first 3 steps, and in the next lecture we will talk more about the 4th and the 5th step. So I'll see you there. Thank you for watching and have a wonderful day. Hello and welcome back, everyone. In this lecture we'll be talking about linear regression. Linear regression is the method that we'll be using to solve a problem. It is a machine learning algorithm, so there is some amount of math involved with it. Now I know that not all of you might have a math background, so this lecture is linear regression without too much math. So it is for those people who want to understand the basics of linear regression without getting into too much math. So let's get started. Observe this table. There is x values and y values. Can you find any pattern between x and y? Pause the video and try and observe. You will find that x is basically connected to y in a very simple way. If you multiply x values with 2, you will basically get y values. What I mean by that is y is 2 times x. Now, imagine if you already knew that y is 2 times x, you can predict y values for any x, right? For example, if you wanted to predict y value when the x value is 20, you can simply do it by multiplying x value with 2, right? So 20 into 20 times 2 is 40. So basically, we can say y is 2 times x, and we can predict y value for any given x as long as we know that y is 2 times x. This is the basic foundation of linear regression. There is some value that we need to predict, and we already know some values. So imagine y is the value we need to predict, and x is the value we already know. So if we can come up with an equation, in the case of linear regression, is the equation is basically y equal to a plus b into x. A and b are constant numbers. So once we know a and b value, we can predict y for any given x. This is how linear regression works. In the case of our previous data set, a value is 0, b value is 2. So y is 2 times x. What that means is that for any given x, we can predict y. This is how linear regression works. Now, our problem with sepal length and sepal width. Let's take a look at that. So in this problem, our y value is sepal width, our x value is sepal length. So our algorithm is basically trying to find a and b. If we know the value of a and b which satisfies this equation, we can predict y value for any given x. And this is how linear regression works. Now, finding a and b value involves a bit of statistics and math. So if you want to know how that works, if you want to know all the mathematical aspect behind it, do watch the next lecture. But that is only optional. If you don't want to get into too much math, you can skip the next lecture and move straight into coding. It'll still make sense. But if you want to know all the details, watch the next lecture. So this is one of the most basic explanations for linear regression that you'll ever find. Okay, so that is all about this lecture where we talked about linear regression without getting into too much math. Thank you for watching and have a wonderful day. I'll see you in the next lecture.
In this lecture, we'll talk about linear regression with math. Okay, so in the previous lecture, I gave you a very basic introduction to linear regression without getting too much into math. But this lecture is for people who have an understanding of statistics and math. So let's get started. Have you ever heard of the line equation y equal to mx plus c or c plus mx? So we'll use that basic equation here. The blue dots that you see are data points, and the red line is a line that connects maximum number of these data points. So each line has a line equation, and we'll use this logic for linear regression. This is the logic behind linear regression. If you compare the equations, y equal to c plus mx, which is basically the line equation, and y equal to a plus bx, which is the equation I told you in the previous lecture that we use for linear regression. You see the pattern here, right? So all linear regression does is that it finds an equation of a line that connects maximum data points. So if we have that line, say if we have the values of a and b, and we had to predict y given x, it's simple, right? We just need to add a plus b multiplied into x value. Simple as that. So this is basically how linear regression works. We formulate a line equation that best fits the data points, and then we use it for our prediction. Now, the tricky part for this is that not all our values are going to be in a way that b is always 2. So for finding a and b, we need a very stable equation or a formula. And that formula is formulated with the help of statistics. So a is basically mean of y minus b multiplied by mean of x. And b is the covariance of x comma y divided by variance of x. So that's all about the theory session. Let's open our studio and make our linear regression model and complete our project. Now I know that this is not the best explanation that you'll find for linear regression, and if you don't know what covariance and variance is, you'll probably not understand this lecture. But I don't want to expand the scope of this course by explaining what covariance and variance is. You can easily find that on YouTube and other so many sources. I'll link that in the resources so that you can go back there and find those if you're really interested in knowing what happens behind the scene. Now, without wasting further time, let's open up our studio and make a machine learning model and implement our first real-world project with R. Awesome! So that is all about this lecture. I'll see you in the next one. Thank you for watching and have a wonderful day. Hello and welcome back everyone. So in this lecture, we'll make our machine learning model. So starting off, we have to make a machine learning model. So let's create a variable which will store that model. So I'm typing in model equals. Now what I have to do is that for linear regression, there is a function in R which is basically called LM. So we'll use that function, and you don't need to know any math for this function to work. You just need to understand the concept behind it. So even if you are not coming from a math background, you'll be easily able to make this. But if you really want to understand what is happening behind the scenes, then you need to get into math. And even if you plan to learn machine learning, it's very important that you learn statistics and probability, because without those, machine learning is going to be very hard to learn. Okay, so I typed in LM, open and close two brackets, and now I had to type in the prediction variable, which is what? Sepal width. So I type in sepal width, and now I have to associate it with the sepal length. So how do I do that? I use the tilde operator, and then I type in sepal length. Okay, so now let's run this. Okay, we have a model created. Now we have to predict using it. So to predict, all you have to do is type in predict, which is basically another function. And inside, you type in the model name, followed by the sepal length value, for which you have to predict the sepal width. Now remember, this value is entered as a data frame. So I type in data, frame, and inside, I type in our sepal length value. So it can be sepal length equals 15. So I'll just clear the console here so that it's easier for you guys to see. Okay, now let me run this. And I got the output 2.49, which is our predicted sepal width for our sepal length 15. Isn't that amazing? You just made a machine learning model that predicts the sepal width given the sepal length. Now understand this. This is not going to be the most accurate machine learning model ever, but this is something, right? So you basically invested 2 hours into a course and you learned the basics of R programming, and you also got introduced to machine learning, and you made something that is close to a real world project. Now this is not going to revolutionize the world or change everything, but at least it's a start. So from here, you can go anywhere you want. You can dive more into data science, you can get into machine learning, you can get directly into R programming, you can do whatever you want. So that was the goal of this course, to introduce you into the concepts, and maybe with that, you can pick up skills on your own. Because nobody can teach you programming, you have to learn it on your own. An instructor can only show you where to look and how to learn. So hopefully with this course, you have figured that out. Thank you for watching. That was all about this lecture. I'll see you in the next one. So I would like to congratulate you for completing this course, and hopefully you learned something out of it. Now remember, this is very important, that we just learned the basics of R programming and data science, and a little bit of machine learning. There is a lot more for you to learn, and it's important that you solidify your basics before you go and learn the major concepts. So if there is some part that you haven't understand properly, don't forget to drop by the discussions and ask those questions. And I'll be always there, and I'll be happy to help you with it. And if you want to learn more about a specific topic, don't forget to add that in the discussions, because I'm happy to add more lectures based on your preference. Awesome! So you just basically invested 2 to 3 hours into an online course, and you learned the basics of data science, and you also got introduced to machine learning. So don't forget to leave a review so that I can reach maximum audience with this course, and more people can get introduced into the world of data science. I hope you have fun, because I had a lot of fun teaching you guys, and I'm sorry if I made any mistake during the course. Do drop by the discussions and let me know so that I can fix it. So for one last time, thank you for watching and have a wonderful day.